Hello everyone. Today we are going to start a new chapter, Autonomic Pharmacology. So at the very beginning of starting Autonomic Pharmacology, we have to recall some basic of autonomic nervous system from anatomy and physiology. Nervous system can grossly be divided into central nervous system, and to connect the central nervous system with the whole body there is peripheral nervous system. Central nervous system is mainly composed of brain and spinal cord, and peripheral nervous system is mainly composed of somatic nervous system and autonomic nervous system. We know that soma means body wall, so our body wall is mainly composed of skeletal muscle. So somatic nervous system supplies a skeletal muscles or voluntary muscles. So, somatic nervous system supplies those organs which we can voluntarily move, and autonomic nervous system supplies those organ or viscera which we cannot voluntarily move. Means the body can control themselves according to physiology, like heart, bronchus, gastrointestinal tract, etc. On this organ, we have no direct control. So, our discussion will be on autonomic nervous system. Autonomic nervous system is mainly divided into sympathetic nervous system and parasympathetic nervous system. This division is made on the basis of origin of nerve fiber. Let me clear it with a diagram. So this is our brain and this is our spinal cord. The sympathetic nervous system is originated mainly from thoracic and lumbar region of spinal cord, and our parasympathetic nervous system is originated from brain, means cranial and sacral region of spinal cord. I am again telling the sympathetic nervous system is originated from thoracic and lumbar region, and parasympathetic nervous system is originated from cranial and sacral region. So how can we remember it? We can remember that sympathy is at the central of our life. So sympathetic nervous system originate from centrally, means thoracic and lumbar region, and parallel or lateral to sympathetic nervous system on both sides, cranial and sacral segment, the parasympathetic nervous system is originated. Then after originating, it forms ganglia as a relay station. The blue marked circles are ganglia. From here we can say that the sympathetic ganglia are nearer to the spinal cord and the parasympathetic ganglia are far away from the spinal cord, or parasympathetic ganglia are nearer to the viscera. So how we can remember that? We can remember that when we have sympathy to someone, we try to keep him close to us. So sympathetic ganglia are closer to the spinal cord and parasympathetic ganglia are opposite. So here we have learned two tricks. One was about sympathetic nervous system and parasympathetic nervous system origin, and another is about the location of the ganglia. Here the black marked nerve fiber are preganglionic fiber because they are prior to the ganglia, and the red marked fibers are postganglionic fiber. And at the end of the postganglionic fiber there must be some viscera or organs. For the transmission of nervous signal from the preganglionic fiber to the postganglionic fiber, there is a chemical transmission which is transmitted through neurotransmitter. In parasympathetic nervous system, the preganglionic fiber releases acetylcholine as neurotransmitter which binds to postganglionic fiber and transmits the nervous signal. The postganglionic fiber on viscera also secretes acetylcholine for neurotransmission. So in parasympathetic nervous system, both preganglionic and postganglionic fiber releases acetylcholine. So here also acetylcholine is released from preganglionic and postganglionic fiber, as they are also part of parasympathetic nervous system. But in sympathetic nervous system, the preganglionic fiber also secretes acetylcholine which binds to postganglionic fiber, but near the viscera, the postganglionic fiber releases noradrenaline, which binds to organs and exerts its effect. So, in sympathetic nervous system, the preganglionic fiber secretes acetylcholine and the postganglionic fiber secretes noradrenaline. But there is an exception. Our sympathetic nervous system also gives nerve supply to the sweat gland. Here, the preganglionic fiber also secretes acetylcholine, but postganglionic fiber, as a part of sympathetic nervous system, had to release noradrenaline, but the exception is that here acetylcholine is secreted. So the gross things we learned from this figure is the sympathetic nervous system originated from thoracic and lumbar region, and parasympathetic nervous system is originated from cranial and sacral region. The parasympathetic ganglia are far away from the spinal cord and sympathetic ganglia are nearer to the spinal cord. How we remember that? When we have sympathy to someone, we try to keep him closer to us. So sympathetic ganglia are closer to spinal cord. The preganglionic fiber of parasympathetic nervous system are longer and postganglionic fiber are shorter, but in sympathetic system, preganglionic fiber are shorter and postganglionic fiber are longer. In case of neurotransmitter, the parasympathetic preganglionic fiber releases acetylcholine and postganglionic fiber also releases acetylcholine. But in sympathetic nervous system, the preganglionic fiber releases acetylcholine like parasympathetic system, but postganglionic fiber releases noradrenaline. There is exception. The exception is that the sympathetic nerve fiber, which is supplying to the sweat gland, that also secretes acetylcholine from postganglionic fiber. So now we should come to the action of autonomic nervous system. We can remember it by a general rule. The general rule is that only organ that is stimulated by sympathetic nervous system is heart, but heart is inhibited by parasympathetic nervous system. In all other organ, this effect is opposite, means that in all other organs sympathetic nervous system inhibits and parasympathetic nervous system stimulate all other organs. Stimulation of heart here means increase heart rate and increase force of contraction. Parasympathetic nervous system decrease heart rate and decrease force of contraction. By other organ we are meaning there is bronchus, glands, pupil of eye, gastrointestinal tract and urinary bladder and many more, but these are must knowing for this chapter. So we had said that sympathetic nervous system inhibits all these organs. So when bronchus is inhibited, there will be bronchodilation. When glands are inhibited, the smooth muscle of glands are not contracted, so decrease in secretion of glands. When there is inhibition of pupil, there will be dilation of pupil, which is also known as mydriasis. When the gastrointestinal tract is inhibited, there will be no peristalsis and development of constipation. When urinary bladder is inhibited, there will be no bladder muscle contraction and there is no micturition. So there will be urinary retention. So parasympathetic nervous system will do opposite to those. Like in bronchus, parasympathetic nervous system will cause bronchoconstriction, which will provoke to asthma, and there will be increase in glandular secretion. When parasympathetic nervous system is stimulated, the eye will be stimulated, that is known as constriction of pupil, which is also called miosis. When the gastrointestinal tract is stimulated, there will be contraction of the gastrointestinal smooth muscle and predisposition of diarrhea. And when the urinary bladder is stimulated, there will be contraction of detrusor muscle and as a result there will be voiding of urine, which is also known as urinary urgency. Here I shall provide you another tricks. How can you remember lifetime? Dilation is mitosis and constriction is meiosis. As you can see, dilation means wider, larger, and mitosis is a larger word, and constriction means narrower, shorter. Meiosis is shorter than mitosis. So meiosis will indicate constriction and mitosis will indicate pupillary dilation. So that's for today. In next video we are going to talk about the basic of parasympathetic or cholinergic pharmacology. Thank you everyone.